Hello everyone, welcome to today's session. Today, I will show you with a memorizing effect, a continuously transforming, glowing translucent object resembling living cells. On the screen left, you can see an early changing luminescent form that almost seems alive. Next, I will guide you step by step through the process of creating this effect. Let's start with the basic setup. Let's start from the scratch. The first step is to convert the screen resolution coordinates to the UV coordinates, making it more convenient to manipulate pixels. Next, we need to set the camera. Now we set the origin of the camera. Then we set the target of the camera. We set it to the origin of our whole space. Now we utilize the set camera function to get the ray direction for each pixels for our current coordinate UVs. Now, with the view direction established, we can compute the color for each pixels based on its UV coordinates to enhance code organization. We utilize the primary rendering logic in a separate render function. We make it the simplest. Now you can see the left screen has become to the white, which means the render function is in fact. Now to achieve the glowing translucent effect, we use a ray tracing algorithm. We implement a dedicated light ray tracing function to simulate how light passes through a thin transparent membrane. The core concept of ray tracing here is to construct a thin film near the zero-value surface of the sight distance function curve. When a ray passes through this membrane, the light field remains stable. Therefore, at each step, we accumulate the color values, creating a natural glow effect. Now, let's make the ray tracing function. The first input is the origin of the camera, and the second input is ray direction, and the third input is the maximum distance for the ray can pass through. First, we make some initialize. And the color is our output color, and which is used to accumulate the color when we pass through the film of the transparent membrane. And the position is to record each step in our light ray tracing, and the basic color is a color that we need to add to our past color. We update the position. We first need to make a map for the glowing object. We make the most simplest sphere. Now we output a box. Now we continue on. Then we define a variable h, which is the distance to the boundary of the SDF surface. We use this. We choose the maxima of h and 0.01 as our ray step to optimize our algorithm. At each step, we make the basic color to the white, and we add it when we pass through it. Oh. Now for the render function, we use light ray tracing. Now you can see it's a transparent cube, right? Which means our first step is successful. By this ray tracing function, we can construct a transparent effect. Now, we can change the basic color to different color by some randomness to make it more complicated. Our random add a new, we consider two reasons, the time and the position. Now you can see the color is become more beautiful, right? And now we can try to make it to the final effect. That is, first we make the outer sphere. But you can see the sphere is too simple. We add it more complicated to its surface. We add some fractal noise. Now, you can see the surface is always changing. It is beautiful, right? Now we can add it to the interior sphere. By the union operation of the SDF, we can make the minimum function of the ulterior sphere and the interior sphere. We make it change more obviously. Or we need to return t. Is too large. Now we can see the effect, but later now we need to change the camera motion to make it more dynamically, and but you can see there here is a problem, and sometimes it will collide with the ulterior sphere, and I want to avoid this. So I can make this. I can make RO and product it by a ratio that that can be controlled. First, we can use the max function. This function means that the camera, the origin of the camera is always in the outside of our spheres, and you can find it. But I want to make it more smoother. Fmax is a smooth of max function. It's a variant of the max function that makes the maxima function to be more smooth. And now you can see. Do you find that it has become more to be more smooth? Okay, let's hope. That's it for today's session. If you enjoyed this effect, don't forget to like and subscribe. I will continue to share more fascinating graphic projects. See you in the next one.